We're building these incredibly powerful AI agents, right? They're designed to help us with pretty much everything. But how do we actually make sure they stay helpful and don't go completely off the rails? Well, we use these things called guardrails. We trust them to keep the AI in check. But what if that trust is built on a lie? Let's get into it.
So first, let's get on the same page. What exactly is an LLM guardrail? You can think of it as the dedicated security system for an AI. Its one and only job is to stand watch, to monitor everything the AI says and does, to make sure nothing harmful, unsafe, or just plain wrong gets through.
I mean, they're basically the digital bouncers at the club door or the firewall on your laptop. They're supposed to be the tireless guardians of our AI agents. They're the whole reason we feel safe enough to let these things out into the real world.
But what happens when those guardians are, asleep on the job? Or even worse, what if they have a massive, critical blind spot that attackers can just waltz right through?
And this is where it gets really alarming. Recent research put some of the most popular guardrails out there to the test. And not just any test, but one with some very specific, very clever attacks. The expected performance, what all the official benchmarks tell us, is nearly perfect, right? 99%. But the actual performance under attack? Whoa. It dropped to 7%. That's not a small failure. That's a complete and total catastrophe. So who are the offenders here? Well, the research zeroes in on two specific models from Meta, LlamaGuard 3 and PromptGuard 2, and they fail for two totally different but equally dangerous reasons. The first one, LlamaGuard, just plain doesn't understand conversations that involve AI tools. The second one, PromptGuard, gets completely confused by the chat's structure, essentially reading it as one giant jumbled mess. Okay, so how are attackers actually pulling this off? Let's take a look under the hood at the anatomy of these attacks and see how they slip right past the guards.
So the first flaw is something we can call the tool role error. You see, LlamaGuard 3 was trained on a really simple idea of a conversation. There's a user and there's an assistant. That's it, a simple back and forth. But modern AIs, they use a third role all the time, the tool, which is what the AI uses to grab data or run another program.
Now, check this out. When LlamaGuard 3 sees a message that says its role is tool, it just doesn't compute. It basically panics, throws an error that says unexpected role, and then it just gives up and does nothing. The safety check is completely bypassed. Any malicious command hidden in that tool's message sails right on through, no questions asked.
The second flaw is a bit more sneaky. We'll call it the context flattening bypass. PromptGuard 2 doesn't actually see the different speakers in a conversation. Instead, it just takes the entire chat history and mushes it all together into one long, flat block of text.
Let's look at an example to make this super clear. Here's a normal, structured chat. You can easily see who's who, the user, the assistant, the tool. But notice how an attacker has snuck a nasty little command right into the end of the tool's response.
And here's the problem. When that conversation gets flattened, that malicious command, ignore all previous rules, it just blends in with everything else. It's perfectly camouflaged. The guardrail literally can't tell the difference between a safe instruction from a developer and a dangerous instruction from an outside source.
Okay, so the guards can be tricked. What's the big deal? What kind of damage are we actually talking about when these systems fail? The impact is really, really bad. An attacker can completely hijack the AI agent. They can hide commands inside of documents or emails or web pages that the AI is just trying to read for you. And in these new systems where AIs can take actions for us, this could mean the AI executes hidden commands, leading to it doing things we never authorized, stealing our private data, or just ignoring all of its own safety rules.
So this all sounds pretty dire, I know. But the good news is the research doesn't just point out all the problems. It actually offers up some solid solutions. Let's see how we can build a much, much better defense.
The paper lays out a really smart four-step strategy. First, use smarter detectors called activation-based probes. Second, use tougher testing, something called Lodo evaluation that's designed to catch the model when it's cheating. Third, clean up the training data itself. And fourth, carefully tune the system's sensitivity depending on its specific job. But let's dig into that first step, because it's a real game changer.
So what in the world are activation-based probes? This is a brilliant idea. Instead of just reading the words in a conversation, this technique actually looks inside the LLM's brain, at its neural network activations, to see what the model is actually thinking. This means it can spot malicious intent even if the words themselves seem totally innocent. It's like a security guard who can tell someone's a threat just by their body language, not by waiting for them to say something bad.
So, after all of that, what's the big takeaway here? I think the most important lesson is that we have to start thinking way beyond these simple, surface-level benchmark scores.
So here are the key lessons to remember. First, and this is a big one, benchmarks can lie, especially if they aren't testing for the right kind of real-world attacks. Second, these modern AI agents that can use tools, well, they come with a whole new set of security risks. Third, our security systems have to understand the structure of a conversation, not just the raw text. And finally, real security means you have to test the AI against stuff it's never, ever seen before.
And that really leaves us with this one massive question. We're in this huge global race to build more and more powerful AI. But as we're so focused on making them smarter, are we remembering to make them secure?
Thanks for watching. It's pretty clear that the race for more powerful AI has to be a race for more secure AI too, and that's a race we simply cannot afford to lose.